All right, good evening and welcome to another one of the UC Davis System Center 1-hour webinars. In this webinar, I'm going to talk about how to use the CH programming language and the System resources that come along with it to create all kinds of different graphical visualizations, to create plots and charts and bar graphs and histograms, and really just overall talk about how to handle a little bit of data with the computer and start to do maybe a little bit more of the mathematical representations. So to get started, the very first thing that I do want to say is if you have any questions, you can put them into the chat and I'll be looking over periodically, and I'm more than happy to answer them as I'm going through and talking about all the different things that I'm talking about. Also keep in mind we're going to be going pretty quickly through a lot of different things, so if it doesn't all click right away, that's okay. This video will be available later for you to re-watch and kind of take a little bit slower on your own time. So to get started, I'm going to go to ChIDE, and I can get there by opening up System Studio. And then on the left hand side, I can just open up ChIDE by double clicking on it, or clicking on it once and then selecting launch. And then just to make sure that I'm starting off with a blank slate, the same thing anybody else would, I'm going to click File and New, and I'm going to go ahead and save this file, and I have a little temporary directory that I'm going to be working out of on my desktop. And I'm going to go ahead and call this webinar.ch. So whenever we want to work with any kind of plotting or data visualization in CH, we have to make sure that we include all of the libraries for plotting and data analysis, etc. The library in CH is called chplot.h. So we can type in the pound symbol include, and again that's the same thing we use everywhere else for including a library, chplot.h, and then we're done. Now if you're really into shortcuts like I am, you can just type in INP, hold Control and press B, and it will automatically fill that include chplot.h. So now the program is going to recognize all of the different plotting functions that we have, and there are quite a number of them, and I can start to create anything that I want. But in order to do that, I have to define my placeholder for my plot. So the way that the plotting is going to work in CH is we define a placeholder, which is essentially another variable, and we send all of our plot elements to that variable. So if we want to draw a line or a point or a rectangle, we would apply it to that variable, which we're going to see in a few moments. And then once we've got all of the setup that we want done, at the very end, we can output that plot. So to start off with that placeholder, we're going to declare a new variable. We're going to call it cplot is the type with a lowercase lot, and you'll notice it turns pink. And I'm going to go ahead and call mine plot. In all of our examples, everywhere that we use plotting, we name our plot placeholder variable plot, but you can name it anything you want. Once I've declared my plot, the next thing that I always like to do is tell it to output my plot. So I would say plot dot, and this is going to say acting on plot, we're going to use the member function, plotting, to finally display the graph. And then always, whenever we use a function, we make sure that it is a function call by putting opening and closing parentheses with any parameters that we want inside. Now, fortunately for this plot.plotting, we don't have to send any parameters. It's just going to be a really quick plot.plotting, and this is going to take care of everything that we need. But again, it's going to happen at the very, very end. So I'm going to leave myself a little bit of space here. Now, what's really great about this plotting library is that it automatically scales everything for you until you start taking the control and start to put in all of those customizations and scales and colors on your own. So to start, if I wanted to say, for example, draw a point, I could use the point function, point member function. I could say plot.point, and then I open my parentheses again because this is a member function, and I can give it whatever parameters it needs. Now, just about everything here in our plotting libraries follows some sort of logical reasoning as to what the input arguments are. So if I wanted to, with pen and paper, draw a point on some coordinate plane, the information that I need to know about that point is where I'm going to be drawing it. So I need an x and a y coordinate. So I can say my two arguments or inputs are my x and my y. Now, this x and y actually needs to be some sort of numerical value. So instead of just saying the letter x or y, I could give it any x value that I want, like 10, and any y value that I want, like 5. And that's all that I need to do to draw a plot a point. And if I click run, it's going to pop up this new window here that automatically scales to the size of my data set. And so my data set at this point is just one point at x equals 10, y equals 5. And if I were to add another data point, it would automatically scale these axes so that instead of going each tick being 0.02 and being zoomed in really, really close on this point, it'll automatically stretch it out. So if I wanted to say plot dot point from, let's say, 15, 7, and I run this over once again, it has a new plot now, and it has scaled it so that both of my data points, as you can see, is my 10, 5 and my 15, 7, they both fit nicely inside of this graph. And anytime that I add more data points, it's automatically going to scale down or up accordingly. So I could add like 2 or 3 more plot dot point, let's say 20, 9, and then another plot dot point 25, 11. And just to be a little bit clear, it draws all 4 of those points. So the next thing that we can do is we can start to connect points, and we can draw lines in the CH language. So once we have a few points selected, I'm going to go ahead and skip down a couple more lines, and I'm going to say plot dot line. It's very, very logical, very straightforward. I open and close my parentheses for inputs. And what I need to do to draw a line, if I were to do this on graph paper, is I'd think about where the line starts and where it ends. And I would need coordinates for the start and the end point. So what the arguments that I need here in CH are the x and the y of where the line is going to start, and then the x and the y of where the line is going to end. So if I wanted to draw a line between these 4 points, I would say plot dot line, and then I'd say the starting point is 10, 5, so x, y of the starting point, and then the ending point is 25, 11. And it's going to draw a line between 10, 5 and 25, 11. And if I run that, you can see it now has a line going straight through all of these points. Now what may be a little bit tricky to see right now, maybe I can zoom in just a little bit by right-clicking and dragging and then clicking again. Oh, it didn't work because I zoomed in too far. If I were to look very, very closely at this point, the line is drawn on top of that point. And that's because the line was drawn last. It's just like if you were drawing on paper. The first thing you draw is what's at the bottom of it, and then if you were to draw over that, you'd have another layer on top, and if you took another color and painted over the top of that, it would start to add layers over and over, and the bottommost layer may end up being hidden eventually. So if you wanted to, say, draw this line and have all of the points drawn on top of it, you would make sure that you just draw the line first. Now I moved that there, I selected the line, pressed Control X, which is the cut keyboard shortcut, and then I pasted it up here at the top with Control V. Now if I run this again, we can see it's a little bit easier to see, but the line is now drawn underneath of the other points. Now one thing you may be noticing is my colors between this graph and the previous graph have changed pretty significantly. The CH plot library automatically selects colors from a list in the order that elements are drawn. So the first color is red, the second color is green, the third color is blue, then purple, then cyan, and after a while it's going to get to a point where it starts to repeat these same colors over again. And if we wanted to change the color that we're using, we just have to use a function to change that color. So let's say I wanted all of my points and lines to be red. I could say plot.fill color and then open parentheses and just tell it a color. I could say red in quotation marks. And if I were to go ahead and run this program again, you can see it started off with red, but not all of my points turned red. I think that's because in order to do all of the points and the lines, I need to do plot.stroke color red. And if I run this again, now all of my plotting lines and points are red. So what this is doing is the fill color is saying we're going to fill in whatever shape we're drawing. So if we're drawing a circle or a rectangle or anything like that, we fill it in with the color that we specify. So in this case, red. If we want to do an outline, the stroke of the shape, so the border box of the square or rectangle, then that is what's going to be the stroke color. Now, because points are considered just point objects and lines are just considered a straight point line, that's why we needed to use the stroke color here. So if I got rid of fill color, this would technically still work exactly the same. And if I wanted each of these points to change colors in the order that I want to specify, I just change the stroke color before I draw whatever element that I want to change to that color. So if I want this first point to be stroke color of, let's say, blue, and then the next one to be a stroke color of purple, the line will be red, the first point will be blue, and the second, third, and fourth points will all be purple because I stopped setting a new color at this point. So if we see this first line is red, the first point is blue, and then we have purple, purple, purple. So whenever you make a change from that point on, just like any other time we're programming, from that point on, the computer is going to recognize that as the color that we're working with. So let's look at another element that we might want to draw. After we've drawn lines and points, we may want to draw an arrow to point at maybe a piece of data. So I could say plot.arrow, and this is another function that's going to draw an arrow shape, and all I have to do is tell it where my arrow starts, so where the tail of the arrow is, and then where it's going to end. And so if I want my arrow to point at the point 15, 7, I would say 15, 7, and then I give it some other point that I want it to start from. Let's say I want it to start from 10, 10. And if I were to draw this now, you can see my tail started at this point and points up to 10, 10, and it's got a little arrowhead here at the end. Now that's not quite right. What we want to do is we might want the arrow to point at this data point, so maybe we could create some sort of a label for the data point. So instead of starting with the point, I actually want to start with where I want the label to be, or the other end of the arrow, and end with the coordinates of the point. So I would start at 10, 10 and end at 15, 7. And if I run this one more time, now we've got this nice neat arrow pointing to that data point. And if I wanted to change the colors of this arrow, I could do plot.fill color red, stroke color red, and it should, oh, I don't know why it's not, but in theory it would have changed the arrow there to be red. I will find out why my understanding there is not quite correct, and I will get this updated in the comments a little bit later on. Anyhow, moving on, you can draw arrows to point to any point in your graph, so it could be to a bar element in a bar graph, you could have it point to a point on a number line. There's all kinds of different ways that you could draw an arrow on your graphs. Next thing that you might want to do is label this arrow, and you can do this with the plot.text. Now, sometimes as I'm getting through with a lot of these different functions, it can be hard to remember either the order of parameters, kind of like I mixed up the order of my parameters here with arrow. And so sometimes I want a reference or some sort of a little kick in the right direction. And that's where I've found, as I discussed a couple of webinars ago, where we have this abbreviations library, where I can type in a function name and use my global shortcut, which was the Control B, and I can autocomplete, filling in that entire function with some placeholders to tell me what is going to go in each point. And so this first point is my string. So if I wanted to label this, I'm going to say it is my point. And then the second argument, I can't really remember what that is off the top of my head, so I'm going to put a 0. And I'm going to see what kind of errors get spit out and reuse those to actually go through and figure out exactly how this works. Because sometimes it's really hard to remember all of the parameters for the dozens or even hundreds of functions that exist out there. And then we have an x and a y, and this x and y, based off of all the information that I'm saying here, is going to specify the point that we are starting at. And so my x, let's say my arrow starts at 10, 10, so I probably want to label at 10, 10. And if I click run, ooh, nothing's happened, and it didn't give me any errors. So what I might want to do here then is look up another example somewhere else of how this function is being used. One place that I can do that is I can go into the documentation section of CSTEM Studio, and I can open up my Learning Computer Programming with CH for the Absolute Beginner textbook, and this is a full textbook that's included with every download of CSTEM Studio. And then I can go into the quick references at the back of the book and scroll down until I find my plotting libraries, which start in B22, and I could find the text function. Now, what I also like to do is use Control F and just type in the word text and hit enter. And you can see it fills in automatically, or not fills in, but finds that section and goes to it automatically. And here it says it's going to add text at the XY coordinate, for example, and it gives you this nice, neat example where this just is the justification of the text, where it's going to say if we want to center it to left aligned, we want it to be centered at that point, or right aligned at that point. So let's look at what each of those might look like. If I go back to my webinar.ch here, I could say plot underscore, I forgot what it was called again, text underscore center. And this is going to center align my text at this point. And you can see it's a little bit overlapping there with my my y-axis labels there, but point is centered at that point 10, 10. And if I wanted to do plot underscore text and I wanted to left align it, I would just change center to be left. And I click run, and now it is left aligned at that point. And same thing for right aligned. I could just switch to right, click run, and now it is right aligned. Now, one thing you may be noticing is that when we are plotting all of these data points and everything, the graph doesn't scale with points. And this makes it so that we could put a label at the edge of our graph without having it scale our axes to some other position. So if I wanted to, say, move my axes off to the side a little bit, I can use another function to start to customize my graph just a little bit. So for example, my point label right here is going off to the side. So maybe I want to extend this off, let's say another 2 points off to the left. So I want this x-axis to go from, let's say, 8 all the way up to 26 looks probably pretty good. So what I can do is use another function called axis range, where I could say axis range, hold Control, hit B, and it's going to autofill. And it says we want to specify which axis we're setting the range for, so either the x-axis range or the y-axis range. We want to give it a minimum value, and a maximum value, and some integer increment. So how many spaces or units are between each tick. So to specify an axis or really any predefined setting in CH, we use these macros that start with plot underscore. So for example, if I want to specify an axis, I would say plot underscore axis underscore, and then whichever axis I want. If I want to do the x-axis, I'd say x. If I want to do y, I'd say y. And if I want to do xy, I'd say xy. And that would set the axis range for both x and y. For this case, I'm only going to do x. My minimum value, we said we wanted to start at about 8. We wanted to go up to about 26. And I think it had an increment of 2 on the previous graph. So I'm going to try 2 and click run. And there we have it. It shifted my axis so that it forced it to start at 8 and go up to 26. And I can change any range, this to be any range that I want. So in a lot of cases, you want your data to start from the origin, so from x equals 0. That way you can actually see a little bit more large scale what everything you're doing is looking like. So if I were to start this at 0 and click run, then you can see it automatically shifted my axis to start from 0, but still kept it ending at 26. So now, one other thing you may be noticing is that the point, a lot of times when we label our graphs, we want the point to be just a little bit over the arrow. Instead of having the arrow be right here at the end, we may want it right underneath the center of our point. So, the center of our label. So what we can do is change our justification on our point to go back to center, and then if we look very, very closely now, the arrow is ending in the middle of the point. And so the justification, or the anchor point for this label is right in the very, very center of all the text, right about there. And so what we want to do, if we want this line to go just below it, is move it up by just a little bit. So it looks like maybe 0.2 might move it up a little bit if I just look at these axes here. So if I say my y value goes to 10.2 and I click run, now we can see point is just above that there, and it's a nice label for this data point here. All right, moving on to another couple of objects that we may be interested in displaying. If we wanted to start to draw any kind of additional shapes or labels or highlight any sections of our graph, we may want to draw some shapes. And so there's 3 different shapes that are really quick and easy right off the bat. We have plot.circle, where we can say draw a circle, where we give it the center coordinates, so where the circle is located, and then the radius, or r, of the circle. So we say x center is, I don't know, let's start off with circling that label, so 10, 10. And my radius, well, that point label was pretty small. A radius of 1.5 would probably have worked out, and I'm just kind of guessing here. And if I click run, it's going to draw a circle around my label there. Oh, but you notice point is a little bit offset there, and it's actually circling the tail, and that's because my y coordinate here should be offset by 0.2 so that it actually centers around the center of that text for the point. So it's all up to how you want to actually customize your display there. So I'm going to go ahead and keep this at 10 because I want to circle that tail end there. Another object that we might want to draw is a rectangle. We might want to highlight or show or circle a couple of data points in our data set. So maybe I'd want to say plot.rectangle and then give it all of the parameters that it needs for a rectangle. So I'd say rectangle and then use my universal shortcut, Control B, and it says plot.rectangle. I give it the x and y, the location of my rectangle, and then the width and height. Now, it's not as obvious right off the bat which x, y this is because a rectangle has 4 corners, but I know from experience that this is the bottom left rectangle, or corner of the rectangle. And then the width and height are how wide along the x-axis and tall along the y-axis we want it to go. So let's say I wanted to highlight these 2 points. I could say start off with my rectangle between 15 and go from 15 all the way up to 20. So I want to be 5 units wide. And then I want it to start at, let's say 0. That way it goes all the way from the y-axis. And I want it to go all the way up. I'm going to go a little bit above to 10. And if I run this now, you can see it has this rectangle that's kind of highlighting this range of values here. Now, I don't really like how it started to add this negative of my graph here. So I'm going to adjust my axes just a little bit here to get it a little bit more centered. So I'm going to say plot.axis range and say plot underscore axis underscore y. And I'm going to say let's go from 0 to, I don't know, 15. And then the last item is the increments, and let's say it increments by 2 again. And if I run this, it starts off with 0 and goes up to about 15, and 0 to 26, just like we have set here, and it's highlighting this range of data there. Now, sometimes when you want to highlight a range of data, you don't necessarily want to just put a box around it. You may want to change the color of that as well. So let's say I want to highlight it yellow. First, I'm going to change the plot.stroke color to be yellow. And if I run that, now a little bit harder to see in yellow, but you can see it started to show up yellow there. Then I want to say plot.fill color. And this is where I was saying a little bit ago that it's going to fill in this shape with the yellow color. If I click run, now you can see I have this nice bright yellow highlighting here on my graph. Now, sometimes you don't necessarily want it to be this bright. You may want to change it a little bit, make it a little bit transparent, maybe do some additional colors on top of it. And we can do that by changing what's called the opacity, so the transparency of our shape. So I could say plot.fill opacity, and I'm pretty sure I'm getting that right. I'm going to double check just to be sure by typing in fill opacity and holding Control and hitting B. And the only thing that it wants is the opacity. Now, when something is completely opaque, so an opacity of 1, that means it's solid. And if we do an opacity of 0, that means it's completely transparent, it's not even visible. So I'm going to go ahead and do right down in the middle, do 0.5, and click run, and you can see my yellow highlighting is no longer quite as drastic. Now, one thing you may have also noticed is that even before I changed my opacity, the line was still being drawn on top of this shape. That just has to do with the order that the library itself handles things. And the way around that would be to actually split this line, if you wanted it to actually go behind the shape, split it into 3 different line segments such that the endpoints of the line are behind the rectangle. So once we've got a rectangle set up, you may also notice, let me change my stroke color here so you can kind of see what I mean. My stroke color is this extra bright red color, and if I change my fill to be red as well, you can see the stroke is this separate color from the main part of the shape. Sometimes when you're highlighting a shape, you don't necessarily want the stroke to be there, and you can get rid of the stroke by just saying no stroke color. So plot.no stroke color, Control B, and that's going to disable the stroke. And so now when I run this, you can see there's no longer an outline of that rectangle. Next up, we can draw a triangle. with the plot.triangle function. And the triangle function is going to take 3 pieces of information. It needs each coordinate of corners of that triangle. So if the triangle has 3 corners, the first, second, and third corners. So let's say if I wanted to do this, I'm going to comment this out for a second so I can look at where my graph is at. Let's say I want to put a triangle somewhere down over here. Let's say between 2, 2, 6, 6, 2, and 4, 6. I could then do plot.triangle and say 2, 2, 6, 2, and whoops, 4, 6. And it's going to draw my triangle, still again following what it already has set from before. So still doing the same red opaque color or transparent color with no stroke, and it's going to draw my triangle wherever I specified. And I could put these coordinates really anywhere that I wanted. So if I wanted to go 6, 6 here, I could do that as well. And you can see it changed the shape of my triangle. So that it used the 2, 2, the 6, 2, and the 6, 6 coordinates. So those are the 3 most basic shapes that we can do. But you may be noticing that the rectangle, it specifies the width and the height. But a rectangle also has 4 coordinates. It has the bottom left, the bottom right, the top left, and the top right coordinate. So we can also move 2 of those coordinates to make a quadrilateral. So if I were to do plot.quad, that's going to draw a quadrilateral for me. And again, that Control B helps me to see what the parameters are. So I have x1 and y1, x2, y2, x3, y3, x4, y4. I'm just going to go ahead and start off with 4, 4, 5, 2, 6, 7, and let's say 7, 8. And if I run this again, you can see, oh, I got my coordinates a little bit mixed up there. It goes 1, then 2, and then the third coordinate is the top right position, and then the fourth coordinate is the top left, which is why we're getting this kind of inverted triangle here. And so if I wanted this to be the top right, I could just swap these 7, 8, and then 6, 7, click run, and there we have it. We have a quadrilateral here. And you could easily adjust these coordinates to make it any kind of rectangle, or not rectangular, but 4-point shape, any quadrilateral that you would like. Now, what if you wanted to draw any kind of regular polygon? There is a function for that, for drawing any regular polygon, and it is called regular polygon. If I hold Control B, then it says we need an X and a Y, which right off the bat is a center point, so the starting point of our polygon. We need the number of sides that it has, and the length of each side. And then this angle, I'm a little bit hesitant to say for sure here, but right off the bat, I would think this angle is the rotation of how that shape is rotated. So let's say we started off with a square centered at, let's say, let's go back to my graph here so I can find a good spot to put it. Let's say we do a square centered here at 4, 12. So plot dot regular polygon. So 4, 12, it's a square, so it has 4 sides. I'm going to say the length of each side is kind of short, 2, and I'm going to say an angle of 0. And if I run this, we have my square drawn, centered at 0, 0. And then if I increase my angle, let's say by 45 degrees, then it rotates my square by 45 degrees. Let's say I went back to 0 and I increase this, and let's say I have a pentagon. And if I run this, it draws a regular pentagon or any number of sides that you want to draw. So I could draw, for example, a stop sign here with 8 sides, an octagon. So that pretty much sums it up for the basic drawing elements that we can do in CH. So what I want to do now is start to talk a little bit more of the mathematical representations that we can do with these plotting. So I'm going to go ahead and I'm going to start off with another new file. I'm going to say File, New, save this one as webinar-2.ch, and I'm going to include my plotting again, INP Control B, and I'm going to include my cplot plot, and last but not least, because I need to do this on every single time that I want to draw something, plot.plotting. So a lot of times, one of the first things that we start working with students on graphical visualization is number lines. And so we can start to draw number lines in CH. And we have this nice neat function called the number line, Control B. And just a quick side note, the capitalization on that Control B does matter. It is case sensitive. So if I were to do number line without that capitalization, it doesn't read it as number line. It just picked up on the lowercase line and filled in plot.line. But anyhow, moving on. The plot.numberLine function is a slightly more special function in that it doesn't have a set number of inputs that we give it. Sure, this global abbreviation fills in 2 automatically, because a lot of times when you're drawing a number line, you're either drawing a point or multiple points or lines along a number line. But the way this works is we say a starting position, so 0 for example, and then where we want the current position to move. So if I said 0, 5, it's going to start off at the 0 position, and it's going to move up 5 to the 5th spot. And then I could do another comma and say from there, let's go ahead and increase again to 7. And if I were to run this program again, it starts off at, let me close this other one, 0 goes to 5, and then from 5 it moves another 7 units to the right. And I could do this either positive or negative. So let's say I wanted to go backwards 5, I could say -5, click run again, and it's going to decrease my current value by 5. It's pretty neat, right? Another really useful data visualization is plotting expressions, and this starts to get a little bit more relevant when you're starting more the middle and high school levels of math. But so if we wanted to plot an expression, a lot of times if we're doing it with pen and paper by hand, we have to go and calculate out a bunch of points along some expression and then draw a line between those points. If it's a curved expression like a parabola, we have to start to approximate and curve our drawing to match, or start adding more and more little points in between. And we could do that here with CH and plot all of those different points. We could say plot.point and then say if x is 1 and let's say our equation is y equals 3x, we could go my y is 3, then do plot.point when x is 2, y is 6, and plot.point x is 3, y is 9, and so on. And we could do that whole same process once again, and if I run this, and just to note, I commented out my number line here so that it doesn't interfere with my two-dimensional plot here. If I run this, you can see it's drawing that line y equals 3x. However, sometimes you don't necessarily want to have to calculate every single point. Sometimes you just want to see the final result. So we could do this function called expression, or it's actually expr. Again, Control B to autofill for me. And the way this function works is you give it a starting x, an ending x, a number of points that it's going to use to plot this expression, and then an expression. So the starting point, let's say I start at 0, 0, because at x equals 0, y is going to be 0. Let's say I forgot to delete this XF here. Let's say I want to plot this, it's a straight line. Let's say I want to plot it with 2 points, because it's going to take the endpoints and draw just a straight line between the endpoints. And then my expression, I put quotation marks, and I write an expression in terms of x. So the computer is going to automatically assume that the y equals is implicit, and all we have to do is the right-hand side of my equation here, so 3x. But there's one other catch here. In order to express multiplication to the computer, just like if we were doing any kind of mathematical equations with variables or numerical equations here, we would have to explicitly state multiplication with an asterisk. That's the Shift 8, the star key on the keyboard. And then I close my quotation marks, and when I run this, it's going to draw, whoops, I misinterpreted here. My starting x is 0, but my ending x is going to be, let's say 4, so it goes 1 unit past here. And then my number of points is 2. And so it starts at 0, 0, and then it draws the line all the way up to y equals 4, following y equals 3x. Now, what if I wanted to get a little bit more crazy with this and say x squared? If I wanted to plot all the points for x squared, I would say plot dot point, let me say x times x for x squared, and I'd have to take and calculate out all the different points along the way. So at -2, it's 4, at plot dot point -1, it is 1, and then plot dot point 0, 0, and then again 1, 1, and finally 2, 4. And if I were to just plot this as is, just those points, you can start to see it's shaped more like a parabola there. But the plot dot expression will do this exact same thing for me. Say I could change my starting position to be -2, my ending position to 2, and I want to do x times x, because that's x squared. When I click run, it's going to go ahead and draw my equation x times x. But you notice something a little bit strange here. Instead of drawing my parabola all nice and curved here, it just drew a straight line. And the reason for that is we only use 2 points to calculate out how to draw this line. And if we use only 2 points to draw a parabola, we have to do a lot of approximation and guessing if we did it by hand on pencil and paper. The computer isn't going to do any of that guesswork for us. It's just going to draw a straight line between the endpoints. So for a parabola, I might need more than 2 points. But just to get the point across, let's draw 3. So this is going to take the endpoints and then 1 point right smack dab in the middle between those endpoints. And it's going to draw lines between those. So it goes in a V shape now. And if I did 1, 2, 3, 4, 5 points, it would match all of the points that I just calculated here. You can see it starts to follow that. Now, if I want to get a really nice, smooth parabola, I just have to start adding more and more and more points. I generally like to just jump straight up to about 100, but it really depends on the scale of your graph and how smooth you really want it to be. But you can see when I increase the number of points, we get this nice, neat, smooth graph here. So that's plotting expressions. From there, we start to get into a lot more of data and actually taking real world information and starting to put it into different graphs. In order to do that, I have to introduce another variable type. So in my last workshop, webinar, we talked just a little bit about different variables, and we're going to be using what we call an array. So in order to use a list or a collection of information, we have to define a list or array of those values in the computer. So we can say, let's say we want an array of values, of integer points for our data here. We could say array int, and that's going to tell the computer our data type is integer, we're creating an array, and we give it a name. And so This is actually a variable declaration, so I'm going to move it up here to the top with my other variable declarations just to keep things pretty consistent and clean across all of my different programs. So I declare this array, and now this is some list of values. But in order to completely declare it, I need to give it some sort of either a number of values that it contains or give it a list of information. Let's say A contains 3 values, and those values are 2, 3, and 4. I can indicate a list of values for initialization here with these braces, and this is just going to say this is a collection of numbers 2, 3, and 4 stored all into this variable A. Now, when working with arrays in the computer, it's basically just a bunch of different values all associated under the same placeholder name. So 2 is part of A, 3 is part of A, and 4 is part of A. To access any one of those placeholders, we just say A, and we use square brackets to indicate that we're indicating an index within that array. And arrays always start counting out at 0. So A of 0 is going to correspond with 2. A of 1 is going to correspond with 3, and A of 2 is going to correspond with 4. So that's just a really, really quick overview of arrays. I think I'll talk about it in more detail at another time, but anyhow, moving on. Once we have an array of data, we can start to create all kinds of different data visualizations. For example, what if my data array here was a bunch of miles per gallon readings that we could collect from various cars. So we poll the class and say, all right, what fuel economy does your car get? Every student in the class says what their fuel economy is, and we add all of those values here into an array. And let's say we wanted to take that list of values and create a histogram. So instead of adding in all these values myself, I'm going to pull up a pre-written example that we have in CSTEM Studio, because a lot of times I like to go from pre-written examples. So if I go to CSTEM Studio, this example is actually in our Integrated Math 1 curriculum. So we can open up Integrated Math 1, then Program, and I'm going to go down to Organizing and Displaying Data. It's section 32, and I'm going to open up a histogram mpg.ch. And again, this is just a pre-written, already done example that we have. And if I click Run, we get this nice, neat histogram of different MPG readings for the car. Now, give me just 1 second. I accidentally changed this a few days ago. Let me revert that back to the default. Here we go. So we have a histogram where we say we have only one car or one data point where it was getting between 5 and 10 miles per gallon, or 9.9. We had 2 between 10 and 14.9, 7 between 15 and 19, and so on. And so the way this is working is we're declaring this array of data points, so just miles per gallon readings, and this could be decimal points because our array is of data type double, which is for decimal values. And then we're doing some additional setup here on our plot. We're saying we have a title, and for the title we just need to give it text. We're saying we have a label for our x-axis, which is miles per gallon. We have a label for our y-axis, which is frequency. And then we are setting up colors for our histogram. And the way this is working is it's 3 different functions kind of working together. So we have histogram color is saying we want each space or section of our histogram to be colored in this order. And it's actually optional to include this. Then we're saying histogram value is going to print out the values on our histogram. Then we have plot.histogram that says first we have this array or list of data points. We have a starting or minimum point for our histogram. So in this case, we're saying the lowest possible fuel economy is 5. The highest possible in our data set is 35, and we quickly skim our data set and see the highest is actually 34. And then we're saying each range of points in this histogram is 5 miles per gallon. And then we set our axis range to be 0 to 40, just some comfortable axis range. And then we go through and we're labeling different ticks on our x-axis so that it's a little bit clearer what we're looking at. So we're starting to see a lot more customization here with our plotting attributes. And if I run this, you can see it creates this nice histogram. The x-axis range is from 0, it goes up, it's not labeled all the way to 40, but it looks like it goes to about 40. This looks like it's about 5 units between 34.9 and the end of the graph. And each section is 5 units long, and it has the data labels here at the top of my graph. And so it creates this nice, neat histogram here. Our title shows up at the top of our graph here, and our x and y axis labels show up next to each axis. And we can set those labels to be pretty much anything that we want. Our tick labels, you can see it creates this little tick mark right in the middle because that's where we specified that it was. The middle of our 5 to 9.9 range is 7.5. The middle of our 10 to 14.9 range is 12.5, and so on. And we end up with these nice, neat range labels. Now, one thing to note, if you're specifying the number of colors or the color order for your histogram, then your histogram has to have the exact number of divisions to it as your number of colors listed. So in this case, I have 7 colors, red, green, blue, etc. Sorry, 6 colors, and then between 5 and 35, that's 30 units, which is 6 divisions. And so when we run this, it has 6 different color options. Now, if I were to change this and say that I want my divisions to be 2 units, and I run this, it pops up an error here down at the bottom saying the number of bars does not match the number of colors specified by the member function bar graph color. That just means we didn't say enough colors here. Technically, we don't have to say what colors we're doing. The program will, again, just like everything else, automatically label all or set up all of the colors for us, regardless of how many different divisions we have. So if I have a bunch of different divisions separated by 2, you can see it automatically colors each one following that order. And we can actually see that the order starts at a red, and then it goes green, then blue, then purple, cyan, yellow, dark gray, orange, light gray, and then it rinses and repeats back to red, green, blue, purple, and so on. So it's just a list of colors, and it will repeat a lot if you have a lot of different data points. There's 2 more things that I want to talk about really quickly before we round up for today's webinar. The first one is we can also generate bar graphs. So I'm going to open up another pre-written example from that same section where we're using another array of data, same kind of style where it's just data values, and we can start to organize these data values in a bar graph. So we can set up that title just like we did before with the x-axis and the y-axis, and then we can say bar graph category, and this is the labels for our bar graph. Much like we set up all the tick labels manually before, this one's just doing it for each category. And then each of these values is the value for that category. And then we say plot.bar graph, and we tell it what data set to use. So if I run this, this is going to generate a bar graph representing the results of a survey for different ethnicities among students in a class. So it says there were 4 students that were white, there were 12 Latino, and so on. And if I wanted to, let's say I wanted to do a double bar graph, where I take this bar graph and I have a second data set that also corresponds with it, I could do that by just adding another data set to my bar graph. Let me pull up another pre-written example we have here, bargraph2.ch. Bargraph2.ch, you can see we have a, whoops, not bargraph2, it was double bargraph.ch. Double bargraph, we have two data sets. We have X and Y. Hang on one second. I think I might have messed up my example a little bit ago. Let me reset back to the original static file because I was playing with these earlier. If I go back to my double bar graph example, there we go. So my double bar graph example actually is two data sets. We have number of male students with certain animal preferences and the number of female students with animal preferences. And if I run this, what's going to happen is it generates a plot where my title is pet preferences by gender. We label my axis pet preferences for X, frequency for Y, or number of students for Y. And then we set up by saying the color of each data set. So we say plot.barGraphColor. We say each data set, so the first data set is blue, the second data set is magenta. We can say plot.barGraphLegend, and we can say that the blue data set is males, the purple or magenta is females. And then we say plot.bargraph, where instead of only doing one data set, we are doing two. We're doing males, comma, female. And it generates this nice, neat looking graph for us. Now, last but not least, we can also generate box and whisker plots in CH, and we can do that with a couple of different functions working together. Really, to generate the plot, all you need is one function. We need our data set, which is a list, in this case, a list of student test scores on a test. And then to actually draw our box and whisker plot, we need the plot.box and whisker. And this is going to automatically set up and scale our plot for box and whisker. And if I run this, you can see we get this nice, neat box and whisker plot with the minimum, the first quartile, second quartile, third quartile, and maximum labeled. In addition, what this example is doing is it's calculating out the minimum, lower quartile, middle, and upper quartile, in addition to the max and range, and printing all of that information out. And it's doing that by declaring variables to represent each of those values and using this function called quartiles, which is we give it a data set and we say we want the minimum, lower quartile, medium, middle quartile, and then upper quartile, along with the maximum, the range, and the interquartile range. And then we can print out all of those values with a printf function, just like we've done in the past. So this is a really, again, quick overview and introduction to a lot of different pieces of plotting, and we've only scratched the surface for plotting in CH. So I hope you all enjoyed it, and at this time I'm going to open it up for any questions that you might have in the audience. I'm going to give it a few seconds because I know there's a little bit of a delay between me talking and what you guys actually see. All right, well then with that, I'm going to go ahead and wrap up for today's webinar. I don't have another one on the calendar yet for January. I'm thinking I might skip January since the first couple of weeks of January most schools are still kind of getting back in, and I might jump back into the webinars the first Tuesday of February. So we'll send out an email in our newsletter with more information, so keep your eyes peeled for that. And again, thank you all so much for joining and watching this video with me. And if you have any suggestions for topics that you want discussed either in more detail or as an overview in future webinars, please let me know. Thanks again and have a wonderful evening.